Okay, so today, our third bit of Pythagoras is we're going to look at some problems. So, the sort of standard questions that Pythagoras questions end up like, because they are pretty formulaic, they do end up pretty much with the same theme every time. There's not an awful lot you can do with Pythagoras. After all, it is right angle triangles and there's only three sides. So, but they do try to get a little bit creative. Now, don't forget, here's our kind of remember, you've got to think each time, am I finding a long side or a short side? That depends whether you're going to add or subtract or not. Just refresh your memory by doing two questions here. Pause the video, write down your working out, unpause when you're done. So here we have a right angle triangle. There's the right angle in the corner. It points at the long side, so this is the long side. So I've already got that. So the one I'm trying to find, which I'm just going to call x, is the short side. Which means if I want to find the short side, I need to square, square, subtract and square root. Okay, but let's remind ourselves up here. Because remember, if you square the two short sides, add them together, it's the same as the long side squared, and 5 is the long side. So if I was going to rearrange this, it would be the long side squared, take away the other side squared. All right, so it is square, square, subtract square root. That's why I am going to do 5 squared, take away 2 squared. Okay, 25, take away 4 is 21. But of course, I don't want x squared, I want x, which means I need to square root both sides. So the square root of 21 is, and I'm going to do the rounding straight off here, 2 decimal places, 4.58. Okay, should be pretty comfortable by doing our rounding by now. If not, go and get some practice. 4.58, 2 decimal places, and that's centimeters because that's what the question's in. Okay, right angles there. It points to that side. So that is the long side. We are finding the long side. We need to square, square, add, and then square root. Remember, this is just this basic version of the Pythagoras up here. A squared plus b squared equals h squared, or some people put c squared. Doesn't really matter what letter you use, it's the same thing. So 12.2 squared plus 14 squared. And this time, I'll tell you what, let's do the square root straight away. Okay, so we're just going to go straight to y. Of course, we've got to square root both sides. Let's make the calculator do the work. It can do all the squaring, adding, and square rooting all in one go. So also inside a square root. To 2 decimal places. Hey, did you get this? 18.57 centimeters. Okay, cool. Right, let's crack on then with some problems. So what sort of things might they give us? Here's one. I don't know why I've put a pause there. I don't want that pause button there. How could we calculate the length of x? Well, here's x. Here's a right angle triangle, and look, it's the long side. And I've got 2 sides marked here. Well, look, this is pretty straightforward, isn't it? What do these 2 marks mean? No, it doesn't mean they're parallel. They're clearly not parallel, they touch. It means that they are the same length. So, this isn't really much different to what I've done before, is it? That long side squared will be equal to 4.5 squared plus 4.5 squared. If we square root that, we will have our answer. So again, let's make the calculator do all the work. So square root of 4.5 squared plus 4.5 squared is, oh, what a lovely surd, 9 root 2 over 2. Let's turn that into a decimal. I'm going to go, oops, let's turn off the subtitles. I, as standard, do 1 decimal place unless it tells me otherwise. So 6.4 in this case centimeters. Now, if you did 2 decimal places, that'd be 6.36. Okay, so that's pretty straightforward. Remember, those little marks mean it's the same. It's an isosceles triangle. Okay, we've got 2 questions here, but I'm going to help you with the first one over here. Let's just take the pause. Oh no, I can't take the pause away. Oh well. I'm going to help with this one, then you can do the right hand one on your own, because this is slightly different to the last one. Because look, what have we got here? I've got the long side, because the right angle points at it, and I've got 2 sides here that are the same. They're both x. Now remember, when we do this, we would square x and square the other short side x, and that would equal the long side squared. So let's sort of do what we can do. Well, 10 squared is 100 for starters, and x squared plus x squared makes 2x squared. I would, in this case, this comes up so much in math, not just with this, but all sorts of things. If you're not sure, formulate the equation that you would do. Do the calculation you would do, just use letters in your calculation instead of numbers, and then see what you've got. See if you can tidy it up, see if you can solve it. Now 2x squared equals 100. Well, that's pretty straightforward. Let's just divide by 2 to get x squared. Well, that means it's 50. And look what I got. X squared is 50. Well, if I just want to know what x is, I'm going to have to do a square root, aren't I? Square root the 50, which would be 5 root 2, which is 7.1 to 1 decimal place. Centimeters to 1 dp. Yeah. Okay, try the same thing on this one. Pause the video, unpause when you're done. Okay, 8, we've got x there. These two sides are the same because they've got the marks on that mean they're the same. And the right angle is pointing at this side to show it's the long side. So I know that if I take the two short sides and square them and add them together, I get the long side squared. Well, 8 squared, 8 times 8 is 64. 8 and 8 till I sick on the floor. 8 times 8 is 64. And there are two lots of x squared, so that's 2x squared. And then solve. So divide by 2 equals 32. And then square root both sides to get x equals the root of 32. We could give it as a surd. I'm not going to. I'm going to do 1 decimal place. It's 4 root 2 if you like your surds. Otherwise, 5.7 to 1 decimal place. Yeah, or 5.66 to 2 decimal places. Yeah, okay, fair enough. Right, so that's one type of problem. Now this one, an absolute classic, comes up all the time. For some reason, maths examiners are obsessed with ladders. Don't know why. Right, a fireman has a ladder that is 13 meters long. If he wants to reach a window that's 12 meters above the ground, how far from the wall, okay, here we go, how far from the wall should he put the bottom of his ladder? Let's give that a letter, let's call it x, that's the distance. Right, with these questions, always, always, always make a right angle triangle. Somewhere in here, there is clearly going to be a right angle triangle. Otherwise, it's not going to be Pythagoras. So there's my one side of the triangle. The wall is the other side. And we would presume that a wall is at a right angle to the floor. If it isn't, like you certainly couldn't do this on the Leaning Tower of Pisa. Although we could work out the angle. Anyway, okay, we can't work out angles. But yeah, if it's against the wall, we presume the walls are straight up, right? Now, one side is 12 meters. 13 meters is the long side. Look, because the right angle is pointing at the long side. So I am finding a short side. I am finding x. So I know I've got to do the long side squared, take away the other short side squared, and that will equal my distance from the wall squared. Remember, we're finding a short side, so to do that, we would rearrange slightly to get that formula. Okay, well, 13 squared, take away 12 squared is 25. That's a lovely round number. X squared. And I don't want x squared, I want x, which means I've got to square root both sides. Okay, let's square root 25 and see what we get. Well, it's 5 meters. It's Pythagorean triple, that. Where all three numbers are whole numbers, we call it a Pythagorean triple. Cool. 5 meters. Yep, just set up the picture. There are three sides. The wall is one side, the ladder's the other. The distance from the wall is the third side of your triangle. Okay, try this one. Pause the video. Unpause when you're done. Do make sure you write down your working out. Unpaused. You betcha. Okay, there's the right angle. The wall makes a right angle with the floor. And the 4 meters is the long side. So the top of a 4-meter ladder leans against the wall, top of the wall. The wall is 3.8 meters high. How far from the wall is the bottom of the ladder? That distance. There, let's call this one y so we don't have any confusion. Well, we know from Pythagoras that one side squared, in this case, will equal the long side squared, take away the other short side squared. Should we put that into a number? Minus 3.8 squared equals 1.56. But of course that's y squared, that's that length squared, and we don't want that. So we square root both sides. Square root of 1.56 is root 39 over 5, or to one decimal place, 1.2 meters. 2 decimal places would be 1.25 meters. Fair enough. Ladders, walls are at a right angle to the floor. That's the key one there. We're making a right angle. Again, let's make a right angle here. A builder has been asked to lay an octagonal patio using square paving slabs. So each one of these is square. What does that mean? It means I know that all of these flat edges are 1 meter. Every little leg side is 1 meter because they are squares. Square paving slabs. To do this, he cuts some of the bricks in half down the diagonal. I think they meant paving slabs there. So there we go. There's a diagonal of 1 because these bits in the corners here are, you know, the half a paving slab is what I'm trying to say. He cuts them in diagonal. Each paving slab is 1 meter wide. What would the perimeter of the patio be? So at the end, we've got to remember, we've got an extra question here. What is the distance around the outside? Make a right angled triangle. We've basically been given one, haven't we? Of which each side is 1 meter. And then that's a right angle. So I'm taking this triangle here and just drawing it there. And what we're trying to find is this length, this diagonal, which is just the long side of my triangle there. Okay, well, let's do it. Let's do 1 squared plus 1 squared. Well, that is 2. And don't forget you need to square root that to get root 2. Now, you could work in decimals, and the decimal would be it's 1.414213562, etc., etc., etc. But actually, I'm going to put that down here, 1.1, just to 3 decimal places. But actually, I'm going to work in surds for this question. You could work in decimals, though, it'd be fine. The length of each of these diagonals can be written as the root of 2, square root of 2. And I know that all the straight edges are 1. So my total perimeter would be 1, 2, 3, 4 plus 1, 2, 3, 4 lots of root 2. So that is actually my answer, and it's in meters. So it's that many meters. But if you did it as a decimal, let's just see what that would be. 9.7 to 1 decimal place. Now that's really accurate, particularly the surds one is completely accurate. That's why surds are so great. And I didn't even need my calculator for that. I just wrote it down. It's a kind of similar thing here. I'm not expecting you to work in surds. I think you're going to work in decimals for this. We're not after the perimeter. We just ask after the length across the bottom here. Think, how can you get a right angle triangle? Because you need a right angle triangle to find the length across the bottom of the window. Okay, pause the video, unpause when you're done. Okay, right, here we go. So we've got a length here, which is essentially we're making a right angle triangle there, aren't we? Of which that's the long side. Just redraw it over here. And the bottom of that triangle is the same length as X. It's the bottom of the window. So all I've done is cut it across to make a right angle triangle, of which I know that side is 65. I don't know the bottom edge. I'm going to call that X. And I can work out the height of this because it's going to be the height difference between these. Right? 80 gets you to that height. But then I just need to go a little bit higher up to here. So that will be the difference between 119 and 80, which is 39 centimetres. So this bit up here, 39 centimetres. Same on my triangle. Oh, the computer has decided to go a little bit slow. Okay, am I trying to find a long side or short side? I am trying to find the short side of the triangle. I see my computer's a bit low on power. Let's give it some more power. It decides it needs power. Change pen so that it's a bit more obvious about where my working out is. Yeah, we're trying to find the short side. So that side squared will be the same as the long side squared. Take away the other short side squared. Square, square, subtract, square root for a short side. I'm going to do that thing where I just do the square root straight away. You can mix and match, whatever you're comfortable with. That's why I like showing you lots of different methods. It's all the same method, really, just a slightly different order. I'm getting my calculator to do all the work. Oh, wow, another Pythagorean triple. That's amazing. 52. That's really satisfying. 52 centimetres across the bottom of the window. Fine. Good. Just make that right angle triangle. I can't say that enough with these. That's what you're doing. Right. You're going to do one of these in a second, but slightly differently. I'm going to show you this one first. You can always pause if you're feeling really confident. But, whatever you think. So I've got two triangles stacked on top of one another. And the important thing here, that side there that I'm pointing at is the hypotenuse of one triangle, but the short side of the top one. Say that again. So that length there in between these two triangles is the long side on the bottom triangle, but it's one of the short sides on the top one. And we need to work out this length here between S and P. Then it goes like this. We'll do it twice. So I'm going to work out RP. Now RP squared, as in that length squared, will be equal to one short side squared plus the other short side squared, because we're trying to find a long side. And that is 267.56. Okay. But now this is the slightly controversial bit. Okay. Now what I really want, RP, is really the square root of that. Because what we just found was RP squared. But let's think about what we're going to do next. I'm then going to use that. That's the long side on the bottom triangle, but it's the short side on the top one. This length here is the square root of 267.56, but it's the square root of that. Now, when I do, this up here, when I try and find this long side, I'm going to do 3.4 squared, which is that side over there, and I'm going to take this side here and square it. I'm going to do RP squared. So actually, I'll be better off just leaving it. I don't want to square root it and square it again. That would just get me back where I was. I hope that makes sense, right? We're trying to, be as precise as possible. So actually just leaving it as RP squared, that's what I need for my calculation anyway. Just to be clear about this, the length of SR squared, which is 3.4 squared, plus RP squared, which is this long side squared, which is that number, will equal the side I want, which is SP squared. That side squared plus that side squared is that side squared, all right? Just sometimes it's easier just to, work like that when you've got stacked triangles. Okay, now that equals 279.12. But we need to square root that because, that's SP squared, isn't it? That's that final side squared. So I square root it to get my answer. Which is to one decimal place, 16.7. 7. It would be 16.71 to 2 decimal places. Yeah. Now this time you're going to do the same thing, except you're going sort of backwards. All right. You've got the long side. You're going to try and find that side there, which is the short side of the top triangle, but it comes the long side of the bottom one. So similar problem. Okay. Pause the video. Unpause when you've done all your working out. Okay, let's try and keep this a little bit neater this time. I was getting a bit messy last time. Right, AC squared equals the long side squared subtract the short side squared on this top triangle. Because that's AC between there. It's the shared side, isn't it? So AC squared equals 15.2 squared, take away 5.1 squared, which is 205.03. Now let's think about what I want to do. That is this side squared. That's not how long that side is. I'd need to square root it, but I'm not going to. Because actually, if I want to find AB, which is the bottom of this triangle, the final length, which is what I need to find, that side squared will equal the long side squared, which is AC squared, take away this n squared, which is CB squared. Now AC squared, that's the thing I found right at the start. All right, so I'm just going to drop that into my calculation. I don't need to square it because it's already squared, but I do need to square that side. Okay, and of course, let's make the calculator do the work again. To find AB itself, I need to square root. Oh, I didn't turn off my pause. There we go. So let's do the square root of 205.03. Take away 4.4 squared. That one does need to be squared. 1 decimal place. It is 13.6 centimeters. It would be 13.63 if you were doing 2 decimal places. Good, nice one. All right, this one's one for you to do on your own, I believe, isn't it? No, I believe. Oh, I've marked up my pause buttons. That's really frustrating, but you know, never mind. Just ignore the pause for now. Sorry, I really hate it when that sort of thing happens. Okay, missing lengths again. In fact, do you know what? I'm going to change my mind. No, I want you to do both of these. There you go. You got a pause on. Have a go. I've changed my mind. I'm fickle. You've got to find the missing length. So I want you to find A and I want you to find B. You've got 2 right angle triangles. So you might need to use one, then the other. Same over here. You need to find C, which is between those 2. And then you need to find D, which is a combination of the whole base there. All right. Good luck. Pause, unpause when you're done. Okay, right. We have unpause no matter what the pause button says. Maybe I can persuade it to go. No, I can't. Okay, A. Right, firstly, we've got a right angle triangle in here, and that's the long side. This is pretty straightforward, this one, A. A squared will be equal to 10 squared take away 6 squared, because we're finding a short side. We've already got the long side, so we're finding the short side. So A itself will be the square root of 10 squared take away 6 squared, which equals, let me just put that in my calculator. Oh, that's a rather satisfying answer, which is 8. So A equals 8, right? We've got that, tick. Then I've now got, I know that is now 8. I want to find B. This is again straightforward Pythagoras. B squared is one short side squared, the other short side squared, and added together. So that's 12 squared plus 8 squared equals 208. But if I want to be, I need to square root 208. Oh, I got that wrong. Right, 4 root 13 if you like your thirds, or 14.4 centimeters. Like that. Easy peasy, lemon squeezy, right? Okay, let's go over here then. So we have, ooh, this is exciting, this one. Now we have got, let's do C first. Now C is part of a right angle triangle over here, where 12.6 is the long side. So I could do 12.6 squared, subtract the short side squared, and that will be the same as C squared, all right? Again, I'm going to make my calculator do the work. Just put it in the square root straight away to find out what C is. Here we go. Here we go now. Right, 12.2 squared. Take away 8.2 squared. Ooh, that's an interesting surd. 2 root 510 over 5. But into decimal places here, 9.0 to 1 decimal place, centimeters. 2 decimal places would be 9.03. So that's C. Well done. Now D, if you notice, now there's two ways you could do this. You could use this second triangle and these two lengths, 10.4 and 8.2, to find the length of EH and add that to C. But actually, if you notice, it's actually a right angle triangle with 12.6 as one short side, 10.4 as the other short side. Add them together, and that will be the same as D squared. Okay, again, let's make the calculator do the work. Let's just square root it straight away. Make the calculator do all of this in one calculation. 12.6 squared plus 10.4 squared. Calculating. Which is 16.3 to 1 decimal place, or 16.34 to 2 decimal places. Now I'm just going to quickly double check that they have actually made a triangle that's correct on here, because sometimes occasionally they make these questions up and they're not actually 100% accurate. Yeah, I think you'll get a different answer. I'm just going to double check. If you did it the other way, this isn't. It's really annoying. I hate it when they do this. Oh, well, did I get it wrong? Hang on, bear with me. Yeah, just hold on. I'm just checking that this is a real triangle and they haven't just made up some numbers, because examiners do that kind of thing, you know. And add that to the 9. 15. I think that if you do it the other way, where you get these two numbers, this length in here would be 6.4, which would make the total 15.4. So if you got a total of 15.4 because you did it the other way, you're probably right. It's just that they've made up a triangle that doesn't really exist, I think. Okay, let's move on. Let's move away from that question, I think. Now this is really useful. No, don't have that. Find the distance between 2 points, 2, 6 and 7, 4. So the way you do this, or the way I do this, is I first of all just draw a little sketch. So let's say that point is at 2, 6 on my coordinates, and another point is at 7, 14. Make a right-angled triangle. Imagine a line between them. Imagine that's the long side. And then make a right-angled triangle. How long have you gone along and how far have you gone up? Well, we've gone from, remember, coordinates are made of x and y, 2 to 7. And we've moved from 2 to 7 across, which means that length is 5. And the height, we've moved from 6 to 14, right? 6 up to 14, which means the height has a difference of 8. It's not to scale, but that doesn't matter. And of course, I'm trying to find the long side. So the difference between the x numbers is 5. The difference between the y numbers is 8. And these are my two short sides. So square one, square the other, add them, and square root it. Straightforward ordinary day 1 Pythagoras, really. Root 89, which to 1 decimal place is 9.4 centimeters, or 9.43 to 2 decimal places. Okay, so find the difference along, find the difference up. You've dropped a triangle, basically. Okay, again, draw yourself a little sketch, or however you want to do this. Pause and then unpause when you're done. Okay, now is the pause does work, but it comes straight back. Nice. Okay, right. 3, 9. Let's imagine that's there. And the other one we're going to say is there at 10, 15. Just coordinates. I've just got a pretend grid here. And I'm trying to find the line straight between them. So I'm going to imagine a right angle triangle. Let's see. Well, we've gone from 3 to 10 on the x. That's plus 7. So this triangle has a length of 7. And from 9, we've gone to 15. That's a difference of 6. It's right angled, and the side we're finding is the long side. So square one short side, square the other, add them, square root it. Square root of 7 squared plus 6 squared is root 85, which is really close to the last one. 9.2 centimeters to 1 decimal place, or 9.22 to 2 decimal places. Right, 2 more for you to do. Important question. So crack on, pause it, have a go. Remember, these lengths can't be negative. Bit of a hint. All right. Okay, I'm guessing you've unpaused. My pause button goes away and then instantly comes back. So let's just scribble it out. Okay, so you can do this 2 ways. I'll draw a sketch for this one over here, I think. Let's say that that's at 2, 4. Now, if my next one is at 6, 2, that's a little bit further along, but a bit further down. So it's like down here somewhere. 6, negative 2. Now I'm going to drop my little triangle. So we'll come to that one in a minute. And actually, do you know what? I think it's always a good idea to draw sketches. So 1, 5, 13, 8. That's a long way along and a bit further up. But again, it doesn't really matter because all you're doing is creating just a little blank triangle for you to put some numbers on. You just know it's right angled and you're trying to find the long side. Long side. Okay, how far have we gone along? From 1 to 13, we have gone 12. How far up? Gone from 5 to 8. That's a difference of 3. So 12 squared plus 3 squared, and square root it. Well, add them and then square root it. And 3 root 17, which to 1 decimal place is 12.4 centimeters. Or 12.37 to 2 decimal places, if you did so. Okay, now this one's interesting. No, honestly. Right, how far have I gone along? 2 to 6. We've added 4 to that. So my length going along is 4. Now 4 to negative 2. That's a difference of 6. Now you might think, well, it's going downhill. But actually, as far as I'm concerned, that makes no difference at all. All I want to know is the straight line difference. I don't care if it's going downhill, uphill, backwards, inside out, whatever. I just need to know the height difference and the length difference. So 4 squared plus 6 squared equals 52. Oh, and of course I need to square root that to get 2 root 13, which to 1 decimal place is 7.2 centimeters, or 7.21 to 2 decimal places. So draw a triangle, just draw a couple of dots, put a line between, drop a right angle triangle, and then have a look. How far have we gone up? Sorry, how far have we gone along? How far have we gone up? It's a bit like finding the gradient in a way. You could use these to find the gradient. Okay, just a one standalone problem for you to do. I'm not going to say it. I want you to read it and do it, please. Right, again, I'm going to unpause, but the pause comes straight back. Oh, so annoying. The diagram shows a path across a rectangular field. So we know that the corners in a rectangle are right angles. So I've got my right angle triangle. How much further is it from A to C along the sides of the field than along the path? So if I go from A to B to C, so A to B to C, well, that would be 70 plus 40, which is 110 meters. Now I want to know how much further is it doing that than it would be just to cut straight across the muddy field. Well, this is Pythagoras, isn't it? Now AC will be the square root of one short side squared plus the other short side squared. Remember, because look, I'm finding a long side, so square, square, add square root. Come on, let's get used to the speeding things up a little bit, but still writing down our working out. 10 root 65, or to decimal places, 80.6 meters to one decimal place, or 80.62 to two decimal places. But that's not quite the answer because it said how much further. So let's find the difference between the two. So 110. Should we just write that again a bit neater? Not like I don't care, because I do care. And let's also change pen color. So 110 take away 80.6 equals 29.4 meters. And that would be just a tiny bit different if you did two decimal places. That's the difference between the two. So make sure you read the question, because sometimes they're asking for other things. But this is exactly the sort of thing you're going to get with Pythagoras in the future. They won't tell you it's Pythagoras. They'll just presume you can figure it out. It's a tool. It's a tool in your toolbox of maths that you can find diagonal lengths between two other sides. Okay? Right, well done. I think that's all we got done for today. So I'll see you next time. Bye-bye.